Check, 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 check. Yeah, let us know, Wes. Snap my fingers. Yeah, you can hear it? All right. Cool.
Can you hear me? Maybe not. Yeah? Project. All right. How's it going, guys?
Do you want to do that before you start streaming?
It's already started. You can go ahead.
Oh, it's not on the right like scene or something. It's just showing the banner. I don't know if that
I
matters.
think it's fine.
Okay.
It's fine. Yeah.
All right. Cool. All right, guys, we're gonna get started. Thanks for coming out to Zane's workshop on Unreal. If you guys haven't signed in, is anybody not signed in? Cool. All right. It's gonna be up here. Just a couple announcements before we get started. We've got our general meetup on Wednesday at 7 o'clock. 6 o'clock? 7 o'clock. It'll be here. And then we've got another showcase event, which is May 5th. May 5th.
Is the Rock Game Fest
Next Saturday.
Next Saturday, by Spielberger at.
No, I'm sorry. This is the Iron Core Library.
This is the Iron Core Library one.
So next Saturday is the Rock Game Fest.
Okay.
So similar to the one we had the last festival in September.
Yeah.
This is like a version of that. Following Friday, we had the Rock Game that one we're hosting spring party that we talked about. This is going to be at a community center called Vineyard. We're in the Spielberger downtown. It's literally the place right next door. It's like a pretty cool community center. All ages. Had a couple of bands playing, a chiptune band, a cover band, and then showcasing at that will be Crazy Plates, Duck, yes, Zach was showing something, and then Sword in the Sun. So we'll have 4 games there, 2 bands. Probably start at 7, end by 10. It'll be a fun time. Hang out and go hang out with Silver after that. So.
And do we know what games are at the Game Fest?
Maybe it's like upwards of 20.
Yeah.
Okay, wow. Cool.
It's probably going to be as big as the event.
Yeah.
So.
Cool. Sounds good. That would probably get started. Thanks, Zane.
All right. So like you said, I'm Zane Draper. I am a developer over at Working Man, recent graduate from RIT, semi-recent. Yeah, we're going to be going through pretty much the basics. I'm going to cover, your intro, usage, and then cover a lot of the basic elements of Unreal. So yeah, we'll just get started. So Unreal has its own hub that you can interact with and get all your engine needs from. You only need to download the actual hub once, which you can do right here. It'll probably make you log in, and I recommend setting up an account if you're going to use it. It'll save a lot of your preferences, any packages you've purchased or downloaded. It'll have a little quick download or add to project if you log in. So it's definitely worthwhile. We will avoid actually downloading it. So this is the hub. This is not the actual engine. When you first download, it's just going to be this interaction. It is a landing page for most of Unreal's stuff. I'll have to forgive my laptop and its internet connection there. But yeah, everything you want to do, you can work right from here. A lot of their projects that they've done are open to you to work in Unreal Engine in their actual game environment. They provide all the assets for you. A lot of their games that aren't open source will provide a lot of the assets, and you can download those right from the marketplace. Maybe. Give it a second here. We'll just go ahead and say this is a reflection of my laptop and not Unreal. I'm not sure what's going on here, guys. Swear it was working like 10 minutes ago. Ran through it all. Yeah. The laptop is super old, so like having an extra monitor attached might just destroy everything. We'll edit this bit out. There we go. So when you first boot it up, it'll usually ask you to log in. You can go without, but it won't really provide any of the extra stuff or really interact with your project too much. So definitely recommend that. In about 20 minutes, we'll actually open the engine. All right, we will skip the hub if we can. All right. So information on the hub while we wait for the actual engine to open. You can install every new version of the engine right from the hub. You can have up to, I think it's 8 or more engines installed all at the same time. You can also download any previous version of the engine up all the way back to the beginning of UE4. They have test builds, beta builds, and they have a new one for Magic Leap. If you're interested in working with that, they have a build that is specifically meant for that that you can work with. Download's pretty quick, and below that you can interact with any packages you want to install right into your project. It works pretty well most days. I was really worried about stretching this out for the full like 2 hours, but it's really helping me along here. All right. So this is what happens when you actually open the version of the engine you're going to work with. This is the project tab. Has everything that's already open or that you've worked with. You can add plugins and things right from the marketplace there. But we're going to stick with the new project tab. So you have 2 options when you're building a project in Unreal. You can go with the blueprints, which is their visual scripting layout that they are super well known for, and it's pretty much the preference when people work in Unreal. If you are building a really, really large project, lots of players, a lot of people are going to be like messing around with it. C++ is the way to go. It really streamlines things. It gets rid of a lot of the extra bog that you don't want to deal with. But for the most part, blueprints are super easy. Templates, or if you're like just prototyping something, it's a great place to start. There are templates for both styles. Everything you can think of, different game layouts, virtual reality, there's AR ones that you can do. Pretty much anything you can think of, they have a build for it. VR and AR I don't think have been added to the C++, but they still are available. You might just have to go on and download the template itself. So we're going to go with the first-person demo for today. It's a pretty good starter kit. Provides a lot of the assets that you need to get started on basic projects. Down here you have your options for how extensive the build is going to be. You can select between a mobile build or a desktop. These aren't set in stone. Once you build the project, you can change the settings at any point you want. We're going to go with scalable 3D or 2D just because my laptop's awful. But maximum quality is if you're building a PC build. Yeah. Yeah. I think I'm going to repeat the question just for the stream. He asked if we start off in C++, can you switch to blueprints? You can. It can be a little difficult. A project I recently worked on, we were going the opposite direction, blueprints into C++, or C++ into blueprints. It was a rough time. We ended up deciding to just create a new project and use our old build as a template for crossing over. So you can, but I don't recommend it. And I'm sure that there are people out there who know the proper way to do it, but it's usually easier if you're just, unless it's a massive project, it can be easier just to go back to a new project. Now, if you are working with blueprints, you can add C++ code to your project. They're not exclusive. It's just the defaults that are provided for you when you create the project that kind of narrow things down. So if you're gonna go for maximum quality, really nice build, definitely go for that, especially if your PC can handle it, or Mac. And then over here we have the starter content. So this is extra stuff that's added on top of any provided blueprints in the template. So we're definitely going to start with that. Anyone who wants to follow along or work on this later, everything we're going to do can be found right in the starter content. You can set where you want your project to go. If you have a separate drive or something like that, and we'll just name this Workshop 1. Create the project. Must have been some connection issues with the hub because everything else seems to be running fine. So a warning I'll give while we're waiting. If you use Unity, switching to Unreal can be a beast because it is much bigger. It requires a heftier computer to work with. There's a lot of payoff for that, in my opinion. But this laptop runs Unity fine. Unreal wavers back and forth. I have to lower the quality settings a little bit. And that can be an issue for some people. But if you have a newer laptop or like a desktop, it runs fine. But it does require a little bit extra. All right, so right off the bat, this is the main landing page. This is your main tab for working with your game and the actual world that you're going to be building in. So the layout is pretty similar to Unity's as far as like tabs go. You can switch between tabs, you can move them, rearrange things, you can separate it into 2 screens if you want, which I usually do. It makes it really easy if you're working in a script or in a blueprint to go back and forth. Some of the basic functionality here I'll go over. Over here are your different modes of basically interacting with the game. If you select any of these guys, the first tab here, you can hover over a lot of your tabs or buttons, and if you hold Control-Alt, it'll actually provide more information and a link that you can go to pretty much find out anything you need. It doesn't work on everything, but a lot of the buttons, some of the buttons, there you go. It'll provide information that you can go through, and it can be pretty helpful if you get lost. The other thing I'll say before we start is up here, next to the top right corner, is a little graduation cap. Basically, those are tutorials that you can run through. A lot of the information I'm going to go over real quick here, you can find right in there. So if you fall behind or nothing makes sense, just start there. They have a bunch of different ones for different types of blueprints that you can find. So it's a good place to start. But over here, we have your basic spawning hub where you can drag out different blueprints and classes into the scene. It's where you usually start for your basic pre-made shapes. So like cube, sphere, you can drag these guys out into the scene, move them around, lights, anything that's pre-made in the engine you can find here, either by finding it in the actual tab or just searching for it. It'll pop up with whatever you need. Painting, I haven't used this myself too much. It can be useful. It's pretty self-explanatory what it is. Terrain, landscape is pretty popular. A lot of people use this, especially if they're doing a more realistic build. If you want to do trees or grass, interaction like that, this is the way to go, because you can obviously shape it just like most other engines. Pretty easy to use. Once you have a terrain, you can paint on grass or trees, different foliage like that. It can be done right here. Geometry is one of your more interesting tabs. It combines with the geometry over here that you can place into the scene, and this is a really, really good tool for level design or level building. If you want to just prototype something super quick, these are great. We're going to go over them a little bit later. I love them. They instead of waiting for an artist to come up with assets or downloading assets, you can block out a whole level super quick and then export it as a mesh that an artist can then work with and then build around to match your specs that you already have for your level. And then this geometry editing lets you take cubes and different things like this, and then you can work with their individual points and then move them to shape them into whatever you want. It's very customizable. It's great to work with. On this side, we have our basic details in the outliner. The outliner shows everything that's in the scene. You can select and manipulate things from this side. Details provides information on the individual object itself. And we can go down through, select the sphere over here. Some basic components that are added whenever you create a mesh. Obviously your actual geometry. If you have an FBX or a model or anything, they'll be there. Your materials, which are your shaders, anything that's visual on the actual object is going to be found here. We'll go over both of those in a little bit more detail when we're working. Physics is pretty useful. Obviously, it's physics. We can simulate with these objects. I guess I'll jump to that real quick. If you want to run your scene or play your game, right up here is the different modes that you can do. So if I go select a viewport, we can actually start the game we're given, move around, built in, and then you can hit escape to end it. But if you don't want to actually play the game, you can go down to simulate, and that will basically start everything in the world, move it around, but you still have a movable camera that can traverse the terrain and see what you need to see. So if we have this guy right here, we go to the physics. You can turn on physics with a super simple click. There's not a lot to it. You can change the gravity, how heavy your object is, all right from there. Simulate, and it's done for you. A lot of what's great about Unreal Engine is how it's all presented right there for you. If you know where to look, you can basically do it without a single line of code. It's super nice. If we continue down through there, we have collision on all of our basic actors that are in the scenes. Actors are any group of objects that can be moved by themselves. All your basic concepts. Basically, if you're a programmer, it's a class. Any type of class that actually has a physical representation in the scene, they're called actors in Unreal. Any individual part of it, so if we look at this guy right here, which is our actual player character, the individual pieces, like you can see the gun there, the camera, those are all called components, which are just added on. But yeah, we go down there. Oops, we're looking at the sphere. Your collision, anything in the scene, if the collision is clicked on, it can interact with basically anything else. It's very customizable as well. You can change every type of object that it can interact with by changing both its type, like the collision type. So if it overlaps everything that's in the scene can be interacted with. It won't stop anything, but it will mark it as an event of overlap, and then you can use that to manipulate different things in the scene. If we do custom, there, you can change everything that it interacts with. So if you have a custom object, you only want it to interact with the pawn, you can click to the pawn, everything else to ignore, and now it's only going to interact with the pawn, which is your player character. Anything that you're moving around in the scene is a pawn. And so if it runs into anything else, nothing will happen until it hits a pawn. It'll ignore everything else. So we'll go back to overlap all dynamic just for simplicity. But yeah, that's pretty much the main amount of stuff you're going to want to know here. There's a lot of information. Everything I'm going to go over, there's 100 more details that you could go into, but it would just take forever. So we're going to skip over a lot of stuff. But if there's anything you're interested afterward, we can check out. But the other quick things we're going to check out real quick is visible right here is pretty important. Actor hidden in game means that it will only show up in the editor, and then once you run the game, it'll disappear. So those are good for widgets or anything that you want to, anything that guides the player or the user while they're actually developing the game. That's what that setting is for. And then if you look down here, editor only means that it will be in the game when you play, but if you build it out to an actual like publishable build, it won't be in there anymore, and you don't have to worry about getting rid of those things later. So you definitely want to delete them if you're going to be building, but having this checked saves you from having to worry about leaving an object in a scene and it gets out there and everyone's kind of wondering what it is. Just saves you a little bit of time, a little bit of worry. So this is our first actor we're going to work with. You can do a lot of stuff with it. It's pretty interactive. This is only a pre-built static mesh that is included in the engine, always. You can work with it, and you're going to build a lot of your things using it, but it's pretty simple. It doesn't have functionality or code or anything with it that will do extra things. That is where we get into blueprints themselves. Blueprints are basically the visual scripting version of a class when you're programming. So we're going to create a folder here where all of our work is going to go, and create another folder in there called blueprints. In blueprints, we're going to right-click. So down here is the content browser. The left side is going to be your folders. Anything that is not a folder, so if your blueprints, meshes, textures, will only show up on the right side. It's an easy way of not worrying about all the confusing. Like if you look in here, you can see there's hundreds of objects. And it's easier than having all that clutter your content browser on the left. If you want to, you can hide it or you can merge them if you prefer that layout. I don't recommend it because there's just a lot of stuff that's in the background that you don't see yourself that can just really muck it up and you get lost pretty easy. But when you're in the actual blueprint side, you can right-click and you can create any type of object that you need to. These are going to be your main ones, the obvious ones. Blueprints, levels are every scene that you make in the game is saved to a level. Materials are the visual component of any object in the scene. Particle systems, fire, smoke, fog, anything like that. Substance is an extra add-on I have. So we're going to create a blueprint class here. And we're just going to call it spinning cube. And we're going to double click to open it. There we go. So one of the things that makes Unreal special, and it's not completely unique, but it has a separate editor for every type of object. So if you have an animation, material, anything like that, you're going to be able to double click it and it will open its own scene where you can interact with it, add to, write the actual script for it. If you use Unity, a lot of times with prefabs, those are built right in the scene you're already working in. Can get pretty confusing, or at least it was for me when I switched over. This makes it so you can add and build your prefabs there, actors, all in one scene, separate from everything else, and you don't have to worry about deleting the wrong thing, mixing it up with other things. Also, when you are back in the outliner, most of your components won't show up in the world outliner here, keeping it from getting too crowded or anything like that. But if you are interested in working in it, usually if it's a pre-made blueprint, you can just click on this edit button over here, and it'll open you right to this guy. So just a general navigation of this. Over here are all of your blueprint-specific properties, functions, macros, all those. We'll go over each of these one by one as we go through. They're very simple to use. If you have any programming experience, it's going to make a lot of sense. Even if you don't, it's very easy to pick up. So we're going to add a component to our scene, and we're just going to add a cube. Now this is the same static mesh we had before, but now because it's in a blueprint, we can actually work with it and edit it. So this is our viewport, just like the main page. You can navigate using the same controls, WASD. If you want to focus on it, just click F. You can use Alt and Control for different types of navigations. Now, if you are moving around the scene and it's going too fast for you, these buttons up here in the top right actually control your camera speed, when you zoom, or if you are like changing the size of the object. This will adjust how far it snaps. So because I changed that to 50, see how it's going to move a little bit, but if we change it to 500, it helps with your fine-tuning when you're moving objects around in the scene. Very useful. Put that back down to 5, recenter it. The other tabs that are right here are the construction script and the event script. This is where you do a lot of your actual visual blueprint scripting. Construction script is run before the game starts. So this is going to be, if you have to set any variables in the beginning, anything like that, you're going to do it right here, and it's going to run once in the beginning before you actually click play. If you set it here, you can actually move the object around in the viewport on your main page, and it's going to update it right there. But for the main majority of us, you're going to do a lot of your work in the event graph. Your event graph is always going to start off with these 3 items. I like to delete them because they're already commented and it just crowds the scene. So we'll just get rid of those. To add them back in, or anything else you need, you can right click, and this is going to provide all of your actions. Actions are functions, basic macros, anything that does some type of programming routine is going to be in here. So if you want to run something at the beginning of the game, like when the game is first booting up, you can do an event begin play. And so this actually only runs once you start the game. Anything you do in here will just run once right in the beginning, and then you will default to any other functions you have, or your event tick, which is your basic update loop. It's going to run once every frame. Very useful. It's probably used the most in the engine, but you have to be careful. A lot of people like to use it excessively for every blueprint they have in the scene, and because of the way they're handled by the engine, it can bog you down real quick. So I don't recommend using them for everything. If you have special events or anything like that, we'll cover how to throw those in later so that they're only called once when you actually need them. So we are going to use the event tick, like I just said not to, but it's going to be super simple. So we are going to bring in, oh, we don't need to bring in, we're going to right click and get our actor's location. So this is going to be the location of your actor in the world. You can also do relative locations on any components that are added, but this will be the actual base location of your whole blueprint. So we can drag out from there, and we're going to, well, we're going to actually right click again, and we're going to do set rotation. There we go. Sorry, I meant to grab the get rotation right there. So basically, we can update anything we need to. right in here. If we need to manipulate the rotation, scale, movement, there are built-in functions for all of those previously, so you don't need to worry about individually calling any of them. So what we're going to do here is rotate this cube that we've made just on its z-axis. Super simple, nothing too big to start with, but we can go here. So on this action, there are nodes, and nodes provide all of the basically transfer of information. Any properties that you have in that function, they're going to come out through right here. This is a rotator. They're pretty simple. You have your basic, it's pretty much a vector, just specialized to use quaternions so that you don't run into any rotation issues or anything like that. If we just want to edit one of them, we can do this button right here, which you can get to by right-clicking. That's split struct. That's going to return the current rotation of all of your objects. So we only want to rotate this guy. We can drag out from there and just click plus. You can do increment or float plus float. That's always my preference in case you need to change it from one. Increment, just like any other programming language, is pretty much just going to increment by 1 every time it's called. So we'll do float plus float, and then you can just change your value right here. So if I want to rotate by 2 degrees every time, that's where it's going to happen. It will return on the other side the new value, and if we want to set it, we just go over here, split this struct, and just plug it right in. Super simple. Go there, compile it, save it, and then if we go back out here, we can drag our spinning cube out. And unless I forgot something, it'll start to spin. But that is going to spin the whole object. If we add a second cube right here, we'll compile, nothing special about that, and then when we run it, it'll spin that one as well. So it's basically everything that's within the actor is all controlled when you actually manipulate the actor itself. But say we want to just rotate one of them. We can go in here, stop running our simulation, and instead of using get actor, we can drag these meshes out into the scene themselves, and then we can get their relative location, which means, or rotation, which means within the actual object actor space, it's going to get its rotation there. So even if you rotate the actor yourself or reposition it in the real world, it's going to not affect the actual rotation of this object. So we're going to split that just like we did before. Bring this down. We can break links between objects by holding Alt and clicking on the node. Like that, and then we'll just delete this guy. We can delete this one. We'll drag another instance of our cube out. And we're going to set the relative rotation. Just like we did before. But now because we're using the actual cube itself, we're not going to run into the issue of the second object spinning as well. So you can control and manipulate everything that's in these actors. Super simple, very easy to do. So that's going to be your first interaction. You can use those to move or scale anything that you have. It's all just set relative scale. You can do location, anything like that for any object. We're going to go to our next one, which is going to be a little more complex there. In case I didn't explain it before, when you are creating a new blueprint, there are a lot of options that you can go through. If you drop this guy, these are all different objects that you can create when you're going, but the main ones, the common classes you're going to use are going to be these guys up here. These top 3 are going to be your main ones. There's obviously descriptions right there, but actor is going to be any just basic object in the scene. A pawn is something you are going to control yourself, and a character is going to be anything that might be animated or walk around or use AI on its own. and they all have pre-built assets that are put in there for you, so you don't have to worry about adding a capsule for collision or making sure the object stays above the terrain or anything like that. Those are all going to be pre-built. You can create them if you wanted to do it in an actor. I don't recommend it. It wastes a lot of time when it's already done for you. So we're going to create a second actor. We're going to call this the door. Open this guy. So we're going to use that rotation that we did before, but make it a little more complex. Instead of adding another basic object, a static mesh that's already pre-made, I'm going to add a custom one that we'll call door. And over here, you can select any type of mesh, which is an FBX or a model that you've brought in or that is already in the engine, to add to your scene. So we're going to add the door. Pretty simple. You can, if you want to change it later, you can change it. They are not locked in on what they are. It's just a basic container for the static mesh. We're also going to add a second one to the root. I'm going to do the door frame. And not that this is going to shock anyone, but we're going to add a door frame. I'm just going to line this guy up, dragging him over, and now the door obviously lines up with the frame. Now you can see that when I click on this door frame, this is your pivot point on the object. So if you are rotating it, it's going to always pivot around that point, which can be helpful. But if you look at this mesh that they've imported for you, they've moved the pivot point. You have to do that outside the engine, obviously, but that helps so that this door now rotates like a door, which can be very helpful. So we're going to go into our event graph, and we are going to delete all those again and set up a basic rotation. So we're going to run this on the begin play. So whenever we launch the engine or run the simulation, it's going to happen right away. Now for this type of animation, super simple. We could use the same layout that we did before, where the door is going to just swing out. But the problem is, if we want it to reverse, we're going to have to add on a lot of extra little details. Or you could use something called a timeline. So timelines are super helpful. We're going to name it door rotation animation. They are basically the same type of animation that we did before. It's going to provide the same type of information, but it's able to be reversed or played from any point in it. So if I set this time to, like, say it's a minute-long animation, we can set it to 0.5 and it'll play from there. Play, stop, and reverse. I'll do the obvious thing. If you are playing it and then you cue the reverse, it'll stop where it is and then go backwards. You're not going to have to worry about updating it or changing a variable to negative so that it's moving backwards. Play from start and reverse from end. Also do the obvious thing. They run the animation from its end point or beginning point. Those are very useful. So we're going to drag that right into play from start. Now, if we double click it, it opens its editor, because everything in Unreal has an editor. So you have a lot of options. You can do a float, which is just going to be a single variable that will change over a given time. You can also do a vector track, which is just a vector changing between two different presets. We're going to add a float track. I'm going to name it rotation. Now once that's added, you can go back into the event graph, and you can see that right here, this output variable has been added to the action. And here, we are going to add 2 key points. And these key points are basically going to control the output across a set amount of time. Add a key. We'll set it to 0 at 0. So when it first starts, obviously, not a lot going to change there. We'll do 1 at 1. And we're also going to set the length of the animation down to 1, because if you leave it at the 5 seconds, there's going to be a lot of carryover. So it'll think it's still playing, even though it stopped at its 1 value here. It'll keep playing through the whole animation, which isn't awful if it isn't doing anything, but it's unnecessary. So we're going to swap that out. Also, I don't know if you noticed, I hit compile a lot. Compiling basically, it doesn't save the blueprint, but it updates your blueprint. So if you switch back to this, it will update it there. But if you wait a long time, you do a lot of changes, it'll take longer to compile, and then saving will just be awful. It'll take a long time. So I just do that as a habit, compile and save every time you make a change. So now we have this timeline, and that's going to run from basically just 0 to 1 values. Now, if no one knows what interpolating is pretty simple. This node covers a lot of the work that you're going to run into when creating them. Interpolation is just you take a value from 0 to 1, and you have 2 values that you're moving between. So if we set this value to 0 and this value to 150, across the span of that 0 to 1, it'll move from 0 to 50. So it's basically just a equivalent movement in time. So we're going to take that. Now what we're going to do with this is we're going to move between 2 different rotations, or 2 different set rotations. When we want the door to open, we are going to have a end rotation and a start rotation, which is obviously going to be 0. So if we look at our door, we are going to want, and we're looking at it from the back right now, we're going to want this door to open a certain degree. So I think the default that I usually go with is 130, and then the original is going to be 0. So that's going to be your start and end, which you can put in right here. Now we can grab the door like we did before with the cube, and set its relative rotation. Grab there. Break it like we did before, and then plug this guy in. And if you wanted to, you could get the door's current relative rotation if it was actually something worthwhile. Right now they're going to be just set to 0, but if we wanted to, we could get the relative rotation, split the struct, and then just feed those values in. But it's just unnecessary. If you know it's going to be 0, or if you know it's going to be something else, you can set them right there and not worry about it. So, compile, save, and if we go back into our scene, drag out a door, and we'll hit simulate. Oops. We need to, okay. Something I forgot to cover. When it comes to these actions, you have your driving node. That's these white nodes that are here at the top. Basically, if a node, or if a action has one of those nodes, it will not run unless you drag out from a previous node to that one. And that's basically how you control the progression of any code you write in the engine. It will only go from one to the next, and you can just keep dragging it out. You can do a return, which will end it. You don't need to. If I just leave it like this, the code will end when it reaches the end of its line. A lot of events, so to start a line of code, you need to call it from an event or function, which is pretty self-explanatory if you have any experience with programming. So if we save that, go back in, you're going to see your door open and close, or open, not close, which is the issue we're running into before. What we're going to do is to control it opening and closing, we are going to use our actual pawn in here to move around and approach the door and open the door when it gets close. To do that, we're going to use collision boxes, which are essential with any project you do. You can add them right from here. You have, if we do just collision, you have a bunch of different types: box, capsule, and sphere. Box is the easiest one. If you know anything about like collision detection, box is the easiest one for the engine to process. It takes the least amount of time. Really not a lot to worry about there. So if you are unsure which one to use, I just always default to box. we go in here, you can see it's basically just an outline cube or sphere, whatever you use. It is an object or a component that won't render in the engine unless you turn off its hidden in-game, which you can if you want to. We'll do that for now just so we can see what's going on. But we'll use our basic controls, size this up. All right, so I'll call this the door trigger. If we go over here, the most important aspect of this is going to be the collision, because it's a collision box for sure. But all this stuff, if you're looking to optimize or if you're worried about performance, you can turn off anything in here you want to. Physics, I always turn off the gravity because there's no reason to calculate it if it's not going to move. So if we go down here, you have your basic collision type. So this is going to look, so this one's going to overlap everything, but like I showed you before, you can change that. If you only want it to overlap a pawn, you can change that down in here. It makes it easy to customize what's interacting with what. It's not going to worry about checking collisions with every object in the scene. It'll only check with those set objects. So if you go in here, the other thing you can do with these triggers is add events to your event graph. All of these are very obviously stated what they do. The most important two you're going to run into are going to be your begin overlap and end overlap on component. They are pretty much the main ones that I've ever used. Some of these other guys, if you are using for UI or anything like that, there is touch begin, on click, on release. They're important, but they're not as frequently used as these begin and end overlap. So if we click plus, it'll just add it right to your scene. I always like to just add both at the same time. So the properties that it's outputting right now, the only three you really have to worry about are going to be the top three on both of these. The other ones can be important when you get into more complex calculations and games. They can be important, but they're really not used a whole lot. So I won't cover them too much. But of these three, we have the overlapped component, which is going to be the name of the component, or the actual reference to the object that's being overlapped in this blueprint. So here it's the door trigger. That's going to be returned here. These two belong to the opposite object that you are interacting with. So this is going to get a reference to the full actor that you're colliding with, and this is going to get a reference to the individual component that you're running into. So we're going to drag out from that, and we are going to use a print string. A lot of debugging in this game, or in this engine, is done with this and print text. They're pretty important. They will print right to the screen in here whenever you need to. So if you're playing and you're running into something, it'll feed any information you want to right to your screen. So I use them constantly. A lot of my blueprints will be 50% just print string, so I can see every step of the way what's going on. It's very useful. So we'll change the string to begin overlap. There. And string. The other thing I'm going to do is I'm going to create a second print string. Not that guy. All right. And I'm going to drag out from this other actor. And I'm going to type get name. So there are multiple different types of names you can get. The most common one you're going to want to use is display name. So display name is the actual name that this object is using in the scene. If you know what the object is named or what its class is named, that's going to be always included in its name. The others can be changed. So I always just recommend using display name. We'll do that from both. And you can just copy and paste. Here. right, so if we play the game now, we go over to this guy, we can see the collision box there. That's just rendered because we want it to be. If we approach, you're going to see the information be printed out on the side there every time we go in and out. So basically that just is to help confirm we're getting the interaction we want. I always like to do that before you spend a lot of time writing out a long script. If there's a bug, you can just get it every step of the way by using print strings. So we'll go back in here, and we're gonna just get rid of these guys. Drag this over here. That. So what we're gonna do is we're gonna use these enter and exits to trigger the door to open or close. So instead of using the play from start or reverse from end, which would snap them into position to start from the beginning, by using play in reverse, we can make it so that the door will just open a little bit and then close if you wanted to, anything like that. Save. If we walk around in here, go from this side, and do that. Now I'm pretty sure, just because the size of the object is too small, I can't walk through it. So if we wanted to change that, we can just go into the scene, expand it a little bit, and then just relaunch. Now that's going to, when you use the scaling or movement function, it impacts every object. Not sure what's going on there. Yeah, it does look like the cubes. There we go. But yeah, you can just expand objects, and it'll control everything that's within the actor the same. You don't have to worry about some things getting squashed, stretched, everything getting out of whack. It'll just control everything the same. So you walk through, close the door. So if we go back to the door, one thing I did want to change was this. So we have the start and end values here, but one of the great things about, I guess it's pretty common among like programming, but of these blueprints is that if I drag out, I can promote this to a variable, which puts it down there in the bottom left. We can name that door end. If I don't want to promote it from there, I can create a new variable just by clicking here, and that'll add the same thing, and I can change its type to any type or any pre-built type or like custom struct or class you can control from right there. So I'll delete this guy. We're going to use this door end value to control what angle we're going to actually open the door to. So if we go to the side, we can click this instance editable, click that, and it's going to allow you to edit per instance in the scene how far your door is going to open. So that door we're going to just leave there. It can open to 130 degrees. But if we bring this door over, we go to details, we can see that a variable has now shown up in the editor, and you can just change that to 30. You want to make it a impassable door for a player who's going by. And if you just walk into it a little bit, you'll see that it only opens to the degree that you've set. That's super useful for any type of game where you're going to be using a lot of a blueprint. You don't want to create a new blueprint every time. If you have different rotations or positions that you want things in, you can just create a variable that's public that you can edit from the main browser or the main outliner. So we'll go back in the door. I think that's pretty much what I wanted to do with the door. Gotta check my notes real quick. Yeah. So we're going to go back out, and we are going to use this to, those couple things, to create a pretty basic game. It's not going to be anything too special, nothing to call home about, but it'll go over the basic interactions we've had. So before we start that, these look pretty bland. There's nothing to set them apart. So we're actually going to create a script, or not a script, a material that can go on those that we can use to provide any textures or any type of visuals that we want on them. So I'm going to go into my folder. I'm going to create a new one called Materials. Go in, and then from the right-click menu again, you can just create a material and call that Cube Base Maps. And then we can double-click to open the material editor. Very similar layout. You're going to get a lot of the event grids. That's where all of the blueprinting happens. So this is going to be your main material component that's going to be in here. You can change this, but you can't get rid of it no matter what you do. It's essential for actually having a working material. So if you go to this side over here where it has details, you can see what type of material you're going to have. If you click your blend modes, you have masked, translucent, additive. The main two that I use are opaque or translucent. Masked is good for if you have a shape and you only want to show either transparent or completely visible objects. So if I put just a square on a texture and I only want that square to show up, you put that into a mask, and then everything else is transparent. If we go up here, we can drag out from this action here and create a constant 3. This is going to represent colors. It doesn't have to. It can be used as a vector as well, but the primary thing you're going to use it for is establishing colors in your material. So that guy, and that's going to change your color there. And this is, you can add a lot of things to it. Drag out from your metallic, create a constant, and we're just going to set that to 1. You can see once it loads how it changes the object to look more metallic. You can work with those. There's a lot of different settings you can do. A lot of these materials get pretty complex. We will actually, I'm going to show you guys one of the materials here. This is a pretty simple one that's pre-built into the engine, or into the starter content. They can be a little hard to understand if you're not super familiar with blueprints or material editors. So starting with your own and working from there is a great place to start. The more you get used to them, the more this will make sense. You'll be able to look at it and know what's going on. But from our own over here, we're just going to go to this guy. We're just going to set it. No point. Set that color, and we're going to apply that to our cube. Here, we have that material here. You can go and select these cubes and just go to the material editor. Once you have a lot of them in your scene, it can be kind of hard to navigate through. So just select your cube base material. And now they both have their own material that you've custom made. Now, you've seen that they can get pretty complex. This is pretty simple, but it's still more than you're going to want to repeat whenever you're working in materials. So one of the good things about these materials, much like the parameters or the properties in the blueprints, is you can actually customize what you're adding. So we're going to add a vector parameter. Just name it color param. We'll delete this guy and plug this one in instead. This is pretty much the same thing. This one is a vector 4, which is going to have a space for alpha. That's going to be your base color. But what makes this one special is that if I go back to my content browser here, I can right-click and create a material instance. And now, material instance is going to have all the properties of the original material, but it'll have a value in here that you can actually change. Why did I? There we go. The other thing about materials is you always have to remember to apply your changes because they can affect so many things, and because they're pretty dense, it won't automatically update the engine because it would be updating constantly for every little change. And it can take a little while, especially if you have a couple dozen objects that are all pulling from the same material. But we go in here, you can see that our parameter group has now updated with a value. We can change that to be whatever we want. Oh, got to turn it on. Change that to green. And then if we go to our cubes again, just like the other ones, we can add this material. And now this material is going to have its own parameters, its own colors if you want it. You can apply your own float variables as well. So if I wanted to do a, just do parameter, scalar parameter is going to be your basic integer float type value. So we'll call this italic param, and that's going to drive just like this value did, but you can change that in every instance. So what makes that kind of powerful is that if we have multiple instances of it, we'll go with red here, update our spinning cube, red. Every single change you make inside the original material is going to be reflected on those. So we're going to customize them a little bit with some textures. Oh yeah, what's up? What's that? So like if I just had like the constant in there? Yeah, the engine doesn't worry about presenting them to the user in the editor, which is always just going to cut down a little bit on time. You're also, if you use all of them, it's going to make it so every variable that you use in your material could be messed with. So say you are an artist or someone who's developing materials or assets for your game, and you present it to a developer and they don't know what all the different variables do that you've made available, they could change them and mess up what you're working on. So you only want to change or present the ones that you know need to be adjusted. So there's not a huge performance difference. There's always going to be a minor one just when you have to add things to the editor. But the main problem is going to be keeping people from messing with the whole material. So the things you want set in stone, you just make sure that people can't edit them on their own. And I guess I'll repeat the question. He was just curious about what was going on with the parameters versus just static scalar values, whether you should use one over the other, if there's a benefit to just using the parameters. So we're going to go in here, and I have a set value that I wanted to use. So because the starter content comes with a lot of materials, there is no point in scrolling through if you know what the name is. It's super useful to be able to type it in and just return the value if you know what it is. All right, so we're going to add this guy. So this is going to customize our material quite a bit. I'm going to multiply by this color. So multiply here, in the background, it kind of does the obvious multiply, but it basically imposes the color that you are providing on top of your texture. So it'll tint it to whatever the user has preset it as. But we're going to provide a base color, just in case. We'll go with a grayish blue there. Because I'm not worried about changing the metallic once we've started, like we were talking about before, I'm just going to change that back into a normal value. less for me to worry about later. So now that we have that done, so the multiply will apply the color to your material, but it's still going to be pretty faded. So we're going to multiply that value again by 10. And we can add a parameter here if we want, or just a constant. But most of these nodes, or these actions, also have the value in the side editor that you can just change there. So I'm just going to set that to 7, and then apply this to my emissive color. All right, so if we go back into here, we can now see that the color that we've added to our own objects, has been adjusted on top of that material, so that it's a pretty good representation of why you would want to do different objects. So now if I want to have different pickups, different objects to interact with, I can visually know what they do without having to worry about replacing the material or anything like that. So the other thing you should avoid is having too many tabs open. It can get pretty confusing if you're just working in one browser. I tend to just let it go crazy, and I'll have like 30 open, but that can start to slow you down a little bit. So I would definitely avoid it if you can. Oops. Yeah. There we go. There's that guy. So there. Now we have two different materials that can obviously differentiate between two objects without actually having to rewrite the code. That's pretty important. We're going to use those now to create the simple game I was talking about. So we're going to go back into blueprints. We're going to create a new blueprint class called damage cube. Open that. We're going to add the cube like before. We're also going to add a collider. All right. So we're going to have to scale up that collider so we can actually see it. And again, you can, if you want to change the scaling value, you can do that here. If you want to more fine-tune it. So if I wanted to get it exact, I could do that. I'm not too worried about it. I'm going to apply the red material here to the actual object. So that's going to be pretty important just to, it really simplifies your working process if you can do things like that. So what we're going to do is we're going to use these objects with the gun that was pre-built to our template here. But in order to get them to interact, make sure that the object the collision is set up the correct way so that it's the way you want it to. So right now, our object is just a stationary object in the world, and isn't supposed to have an effect on it. So if we go in, click the box, we are going to change this to custom, sets it to world dynamic. So we are not going to want it to interact with anything else other than a projectile. So a projectile is going to be any preset object, like the yellow bullets that we're firing. Those were made by the template, but they are set to be projectiles. Before, we were set to block them, which meant that there's going to be no interaction. So if we had created our on component begin overlap, it would never overlap because it's considered a blocking object, which means it does more of it focuses on the physics. It's going to send it back at you instead of causing any type of overlap event. So we can go in here now. Now we want to focus only on the yellow bullets that we're firing. I believe they're called first player projectile. Yeah. So first person projectile. Those are what we're going to want to focus on. A lot of times when you have these overlap components, you want to be really careful, because if down the road you create a second type of object that uses the same type that it's looking for, there could be issues where, you know, a giant rocket that you're using later, you don't want that to interact with your component. So you can use the getName function like we did before. See if it contains the name of the object that you're looking for. If I can spell it right now. And that's going to return a Boolean value. So in blueprints, there is a basic representation of all programming values, or like sequential events. Can't think of the right word for those right now. So if you're looking for a if gate, they are called a branch in here. So a branch is going to represent any values you have. So if you go in, it gives you a driver for true and a driver for false. So you can basically build your logic off of that. So if I only want it to run when it hasn't hit an object called first person projectile, you just branch off false. A lot of times what I do, again for debugging purposes, if you do a print string, you can just put a little note to yourself that the projectile was not recognized. But we're going to focus on if it actually collides with it. We're going to want to do a couple of things. First of all, we're going to want to get rid of that projectile. We don't want it bouncing off. We want it to have an effect. So what we can do is destroy the object, and we can drag out from here to this. If you're like me, you like to keep these pretty clean. It can get pretty crazy with wires just going everywhere. So one of the great things is if you double tap on the wire, you can create just a middle node to kind of navigate your wire how you want to. Put that up there. Just keeps it out of the way, keeps lines straight. You don't have to worry about them overlapping. You can follow along pretty quick with where the nodes go. So we'll leave that to there. It's going to destroy that actor. The second thing we're going to want to do is have some type of effect when we actually hit the object. Particle effects are huge in Unreal. A lot of people love them. They work really well. They can get very detailed. And there are several that are included with the starter content. So we are going to spawn an emitter at location, which means it's basically just going to take the location of your object and create it there. We'll grab the explosion emitter, and then we're going to destroy our own actor, which is going to be the actual cube that you're hitting. Go in there. The other thing we're going to want to do is this will default to 0, 0, 0 in world location. Because it's not attached to your object, it will, any location you put in there, any coordinates, it's going to go to there in world space. So we're going to want to grab our actor location, which is going to return in world, and then just set that. So it's going to destroy the object and then spawn an explosion wherever you happen to have it. So if we go in here, provided so you can shoot the object and it's just going to explode. I don't know, we'll turn up just for this little, maybe. There we go. The other thing we might want to do is have audio. So Unreal has pretty great 3D audio. It can place it anywhere in the world, handles all that for you. Alright, so we're going to spawn sound at location. You can go in here, and it's going to have an explosion audio already built in. And just like that, we can go in. It's going to play the audio. Just 'cause. Oh. Also might be because I didn't set the location. We'll see real quick. Sending audio somewhere else. But yeah, if you could hear it, it would be making a explosion noise, which is pretty cool. It's really simple to set those audio cues up. If you have audio to fill in, they're really easy just to plug in wherever you want them. Yeah, so that's going to be our basic functionality for getting destroying the object that you have. But the more you add to these functions, the more the wires can just get all over, like I was saying. A really easy way to deal with that is to create a custom event. And these are events that have whatever logic you want them to. So we're going to just call this destroy cube. I'm going to grab this logic, and again, to break the actual connections, you can just click Alt, drag this guy down to here. Custom events are really important. You use them a lot, but they only exist in the event graph. They are separate from actual functions. They don't have a return value. You're not going to be able to return a vector or any information back to where you called it from. You can only call that line of code. You can then string another one along afterwards. If you have a spawn new cube after that, you can link that up, but it won't return any values. So we're going to destroy our actor here. What we can do is set inputs. So because we're going to want to destroy an actor, and we can't just link this down here because they can be called at different times. So we could call this destroy cube later. We don't want to link that to a value that might not be set when it's being called. So we are going to add an input, call it an actor, and we'll call it object to destroy. Right, if we go back up here, on our true branch, we can then call destroy cube, and it will have an input for this parameter that we want to destroy. Compile that. Nope. Let's try. Sometimes it takes a minute for it to update. So if you couldn't see before, it said new parameter there still, which just means that when I created it, it was still processing the new function. So I just needed to update it, which you can do by right-clicking and just click refresh nodes. If I decide, oh, I want to add a new variable here, I'll just leave that called new param. Down there it's going to be the same, but sometimes when you already have a call to that event somewhere else in the blueprint, it won't update and you'll get just a compiler error. All you have to do is just right-click, refresh nodes, and that'll clean that up for you. It's updating on its own right now just to prove me wrong, but so we'll go back out. If we run this again, we'll just clean it up a little bit. So the other thing we're going to want to do is affect the player in some way. So this is going to be a damage cube that when you shoot it, it's going to explode. It's going to hurt the player. So we're going to want to find a way to actually interact with the player and present that information to the player. A great way to do that, this is a horrible segue, is UI, which we can set up a HUD. So we'll go in here, just call this UI. So in Unreal, the HUD or UI is called a widget. So if you right-click and you go down to User Interface, you can create a new widget blueprint, which is going to be any visuals that you're going to see on the screen. So we'll just call that HUD. We can double-click to open its editor. So in here, it's a little bit of a different setup just because the actual windows are set up into two different ones. So you have the designer, which is the graphical interface for actually placing objects in your HUD. But if you switch over to the graph, you have all of your parameters, your properties, the actual event graph that you can interact with. So it's super useful to have this place to like visually see what you're creating without worrying about it being in the scene beforehand. So right now, as I'm editing it, because it doesn't exist out here, I don't have to worry about it popping up in the scene or like forgetting to take it out of the scene. I can just edit all of my UI stuff right here and then worry about putting it in later. So what we're going to do is we're going to create two properties. We're going to create a health bar and a score. So for a health bar, we're going to drag in this progress bar. And basically this progress bar is a slider that can fill up or decrease with values. It can be, you can apply different visuals to this. If you have new assets and everything, you can actually add that and update it, and it will provide the functionality for that slider property. So we're going to just bring this guy out, change the color to red-ish, and then we're going to relabel it to health bar. You always want to, you can add a lot of these in here, but you always want to relabel them. They're given really odd names, so you cannot guess what they're going to be. So if I add a new text box, it's text box 37. Why it's 37? Where are the other 36? Don't know. But it just really helps if you need to access them outside of the blueprint to rename them what you actually need them to be. So I'm just going to come up with a little label here. Call this health text. Change the actual text value to health. We'll drag that down here. So another thing that's pretty useful and exists in most engines is the anchor value. So the anchor sets what it the object in the UI actually connects to in the screen. So if we have this guy right here, we're going to attach it down to the corner. And that means if the screen size changes or anything like that, it's going to move to wherever you need it to. So if the screen like shrinks in sideways, you're going to adjust to accommodate that. And you're not going to worry about this, popping off the edges here or getting hidden or anything like that. We will copy and paste that. Move that up here to score, or change it to, to score. We'll change this one to the integer value. All right, so those are going to be pretty important. I'm only going to worry about, for time's sake, I see it's almost 9, about relabeling this one real quick. We'll just name that score value. So in order to make use of these, you are going to want to bind them to variables. It's the only way for you to really interact with the UI is to bind them. So we're going to go and find our first-person blueprint. And it's going to be our first-person character. And the first-person character, don't worry about all this extra text here. It's basically just what controls your movement, anything like that. If you're creating a custom character, you have to worry about playing with that kind of stuff. So we're going to go in here, and we're going to create 2 new values. We're going to create a health value. And we're going to create a score value. And we're going to change these to be integers so that they can't be too crazy of a value. Compile, and we're going to leave the score with its default value at 0, but we're going to go to health and we're going to set that to 100, which we would assume would be the max. And now that we have those set up in our first-person character, we can actually go into the HUD. And when we have the value selected, we can click Bind and create binding. And we can get the character, get the player character, And this is going to be whatever the first player's character is going to be, whatever the current player playing, or like the main user, that's going to grab the information for that character. So, brief explanation, these characters are their own special class, which you always add, and when you are creating a level in a game mode, it can reference that object directly, so you don't have to worry about creating references to it. It knows what to look for in that object, and then it will always just provide a reference to it. So by default, the engine will provide a getPlayer character. It knows that it's this one that I'm using, so I can cast it to first person character, link that up, and I can get the values that are in that first person character. So we're going to get the score, and we're going to use that to set the score on the HUD. Do that. And that's every time the score is updated, it's going to call this and update it on its own, and it'll just reflect on the HUD. We're also going to do the same thing for the health bar. But I don't know if you guys noticed, the health bar itself doesn't have a value from, it goes from 0 to 1. So 1 would be it at its fullest. You can think of it like a percentage. So if you feed in right off the bat the value that we have of health at 100, you're not going to get anything other than just a full bar. And it does fill up past the bar, so if you have 50, it counts itself as 50 times longer, and you'll have to subtract 49 to actually visually see it again. So you definitely want to avoid that. Do the same thing. Oops. We're going to get the health this time. But because the health is set on a scale of 0 to 100, we're going to have to divide that by 100 just to get it into a usable format for our health. Oops. That'll have to convert to a float as well. Set this to 100. And so now that information is going to be applied to the HUD, and it will update as soon as you start the game. So to apply a widget, you can go into your first-person character. And again, don't worry about all this extra stuff that you're seeing here. It's a lot of just setting up the controls, input, that kind of stuff. If you take a little bit of time to look through it, it will make a lot of sense. But we're going to just grab this guy, which is the event begin play. And we are going to add another one of the most common actions that you can use, a sequence. And a sequence is a great way of keeping your code in order, in control. And basically, no matter what happens on the first string, as soon as that first string is done, it will progress to the second string as well. And that lets you control your code. Instead of having like a line that's like 6 graphs long, you can have it, right above itself. So what we're going to do is we're going to add the HUD to our screen. So we're going to create widget. We're going to call that HUD. Now we're going to promote this to a value, just so we have a reference to it in our blueprint, which is really useful if you want to edit anything manually on the screen. You can do it right from there. And then we're going to set this value to viewport. And basically that just makes it so whenever you click play, it's adding it to what your actual player sees. So if you go in here, you can see that it's been added to the screen. And now any updates you do in the actual HUD widget will just reflect there. You don't have to worry about updating that or anything. It's very simple to use. So what we actually want to see, I guess, would be the actual interaction with that. We want to see it adjust. So for the sake of time, what we're going to do is add some key inputs. So they are called events in here. So if we go up a little bit, we can see that there are events for every type of object or controller that you could use for your mouse, gamepad, anything like that. If you go in here, you can see there's every key on the keyboard. You can install packages if you have special keyboards or anything like that. My favorite to use for if I need to just demo stuff is Z, X, and C down on the bottom left of your keyboard. It's pretty simple. That's nothing to do with Unreal, just preference. So just use these guys. All right. Yeah, wrapping it up. So we're going to add our properties in here that we're going to adjust. So we can do the same thing that we did in the HUD and just grab the health. We don't have to worry about calling it since we're in the class. And so what I'm going to do is I'm going to subtract from the health every time you press Z, which is pretty simple. All right, so every time we actually press Z, it's going to subtract from health. And we'll do the same thing for the score. But instead, we're going to just add 10 points. Right. So those are going to change the values in here, but because the HUD is bound to those variables, it'll update the HUD as soon as they're changed as well. So we can click play, and if we press Z, you can see that the value has dropped. But if you see X, it's going up every time I press it, and that's basically just driving the value from the player controller into the HUD. But yeah, there are other examples I was going to do. Got a little behind with the delay in opening the engine. But if anyone is interested in seeing any of the extra stuff, definitely just reach out to me on Discord. I'm on there. And I'm more than happy to answer any questions, anything that we didn't cover today. Yeah, I think that's about it. Wrap it up. Yeah. No, it's a lot of information. All right.
Thanks everybody for coming. We did stream this, so we'll archive it and it'll be up there so when you visit it and go back to it. But like Zane said, hop on the Discord. We'll be posting we have the help me code and all the other cool checks. We're getting a lot of
Probably right, music, everything you do inside that.
it's been good seeing work on it. But those of you who are at the final week, thanks for coming. I mean, it's pretty awesome. But yeah, Jim will meet up next week, next Wednesday.